Okay, the last thing that I want to record here is some information about why this is called hyperbolic sine, hyperbolic cosine. That may be a question that's interested you. And then when do we use what? When do I use the definition? You know, sinh is e to the x minus e to the minus x over 2. When do I use the derivative rule? That kind of thing. So let's first talk a little bit about why this is called hyperbolic sine and hyperbolic cosine. And to do that, I want us to remember a trig identity that you should be familiar with. We've talked about this quite a bit in class. Sine squared plus cosine squared equals 1. This actually comes from the unit circle and the Pythagorean theorem. So if I were to draw a circle here, and I have a right triangle going on right here, so this radius is 1, and let's call this x value a. I've got x going on already, and let's call that value b here, and let's call this angle right here x. We'll notice that the sine of x is actually, SOHCAHTOA tells me that that's b over 1. So that's just b. So the sine is actually b. So this is the sine of x. And as you may be able to guess, the cosine, ka, adjacent over hypotenuse, a over 1, the cosine is actually a. So if we simply apply the Pythagorean theorem here, we get that cosine squared plus sine squared equals 1. And this should remind you a little bit, this equation should remind you a little bit of something like x squared plus y squared equals 1. This is the formula for a circle, which is why trig functions are related to the unit circle. So in a similar way, hyperbolic sine and hyperbolic cosine obey a similar though slightly different identity. You end up getting that cosh squared minus sinh squared equals 1 here. And this, we don't really need any unit circle or anything to prove. We can actually just use the definition of what's going on here. So if I say cosh squared minus sinh squared, let me just plug in what our definitions are here. So here's cosh minus, and here's sinh. Okay, and I'm going to square those out here. So the 1/2 squared is just going to give me a 4th. And if I square this out, I'm going to get e to the x times e to the x, which is actually e to the 2x, plus 2 copies of the inner and the outer when you're foiling. So 2 e to the x, e to the minus x, and then plus e to the minus x times e to the minus x actually gives you e to the minus 2x. And then minus, when I square this out, again that half squared becomes a 4th. And I've got e to the x times e to the x is e to the 2x. But the difference here is I get a minus the middle terms. But this term right here when I square ends up giving me e to the minus x times e to the minus x is e to the minus 2x. So if I look at this, I've got 1/4 e to the 2x minus 1/4 e to the 2x, so those terms are going to end up canceling. And I've got 1/4 e to the minus 2x and minus 1/4 e to the minus 2x, so those terms are going to end up canceling. So I end up getting 2e to the x, e to the minus x, minus minus is a plus, 2e to the x, e to the minus x. So I get 4 of those, and that 4 is going to cancel that 4 down there. So we're just going to get e to the x, e to the minus x, which is actually e to the x over e to the x. So that's just 1. And this should actually, this equation should remind you in a similar way to what was going on with the circle. This should look a little bit like x squared minus y squared equals 1. And that equation, it's maybe been a while since you've done high school geometry, but that's actually a hyperbola that opens in the x direction. So that's why these are called hyperbolic sine and hyperbolic cosine. Now, based on these 3 lectures, what are the things that I really want you to remember? Here's kind of the takeaway. So first of all, you need to make sure you know these definitions of sinh and cosh. So you should be able to write these down by now. Sinh and cosh. Okay, you should also have a vague idea of what their graphs end up looking like. So that's sinh and that's cosh. Again, just kind of quick and dirty graph. If you have trouble memorizing this, just stick it on an index card. You should also remember that the derivative of sinh is cosh, and the derivative of cosh is sinh. And it would be good to remember that last identity that I told you about here, that cosh squared minus sinh squared equals 1. So now if you're given any sort of question on the homework or on an exam in any context where you're asked about definitions of or derivatives of sinh and cosh, then you want to use these 2 formulas that we derived. They're very simple and they involve the derivatives. In any other instance, you generally want to just go back to the definitions and just stick in e to the x and e to the minus x and work from there. So if you're asked to prove an identity, if you're asked to plug in a number, like if somebody says, well, what's sinh of 0? It's a lot easier to just plug in 0 into this equation here. If you're asked to evaluate a limit, anything besides a derivative, generally you go back to the definition of sinh and cosh and just use those. But if you're given a derivative and you're asked to differentiate, then go ahead and use these rules here. So make sure you memorize these, and you should be good to go for the 3.11 part of the WebAssign homework.